Okay, we're talking about matter in the periodic table. Yesterday we looked at what lightning is, so let's talk about that. Lightning is made up of something, but what is it made out of? So lightning, just like everything, is found in one of four states of what we call matter. And the four states of matter are solid, liquid, gas, and plasma. And next unit we'll learn more about these. But plasma is the most abundant form of matter in the universe. And examples of plasma you have over here, lightning is one of them. Solar wind, aurora borealis, fluorescent lights, and nuclear fireballs. Those are plasmas. So we'll learn a little bit about plasmas today, but we'll focus on them a little bit next unit as well. Because our question today really is, what is matter? So what do you notice about plasma compared to the four states of matter that you see? You have solid, liquids, gases, and plasma. As I look at what they look like, solids, you have these blue things. Those are molecules, and then I look at plasma. I have molecules, ions, and electrons. So something happens special to plasma that is different from all the others, and it happens when I continue to add energy, or heat. So plasma has particles that have positive and negative charge. Those are called ions, and they have green little dots as well. Those are called electrons. So in order for a plasma to form, these atoms or molecules, these blue things, they have to become so energized that they give up or take electrons. And this forms the ionized gas that we know as plasma. An example of that would be lightning. So again, feel free to pause if you have to get those notes still. But I'm just going to continue on. So our states of matter, like if I were to take a cloud and break it down, I have water in there. I might have some other compounds in there as well, but I break it down to the smallest part. And what is matter made out of? Matter is made out of atoms. And atoms have different combinations of protons, neutrons, and electrons. So these combinations result in all the different elements you see on the periodic table. And that's where we're going to focus this unit, is the periodic table, which is basically what everything is made out of. So all matter, and we're not going to go through this very specifically, is split into two specific sections. We have pure substances and mixtures. We're going to focus only on one area here, the elements, and eventually we'll get to compounds and mixtures as well. So elements, it's only made up of one type of atom. Okay, so one type of atom cannot be broken down with chemical reaction. Has a positively charged nucleus and negatively charged electrons in what we call orbitals, and we'll learn more about that later this week. So think about organization. Every day we organize things, whether it's our closets, our dressers, our lives, or our iPads, whatever it might be. So think in your mind, what is one thing you organize and how do you decide to organize it? And why did you organize it? Well, one of the things that I have in my life is my closet with all of my clothes, and I have things organized by I have shirts and pants in separate areas, and depending on the shirt, you have short sleeve, long sleeve, you have formal, informal. So within it you have these like separations, and you tend to group things together based on properties they have in common. And the periodic table is organized very similarly. So if I were to look at it, it has increasing atomic number, that's those numbers right here. And then it also has special sections. And each box represents a unique type of atom. Okay, so if I look here, I have my alkaline metals, alkaline earth metals, transition metals, lanthanide, actinide, metalloids, halogens, noble gases. I have a lot of different special groups in there. That would be, like in my closet, the short sleeve shirts for only formal occasions. It's a very specific type of something. But all of them together are clothes. And if I look at each box here on the periodic table, like silver right here, it's a very specific type of a broader category, all these being clothes, or what we call elements. And elements are the things that make up everything. They are the building blocks for everything that we see. And the first attempt to organize them was in the 1700s, and since then many revisions trying to organize them were provided. But the modern version that we use was started in 1869, which is a long time ago, by a dude named Dmitri Mendeleev. And he organized elements by the properties that they had. And simply based off of this, he noticed that there's a lot of gaps in his periodic table. And he was able to therefore predict their characteristics of the missing elements. And then over time, we're able to over time we were able to figure out what those elements were. So think about metals as an example. What are some of the characteristics they have in common? And maybe you thought shiny or able to conduct electricity or malleable, and that might be true, but metals are also a broader category than what we often give them credit for. So the periodic table groups similar elements together, and it makes it easy for us to predict what properties or how things will react or what it looks like and things of that matter. So we call that the periodic law. The way that it's organized based on number of protons, similar properties occur in a regular pattern, and that's what we see. The periodic table also allows us to predict the electron arrangement around our central nucleus, which we'll learn more about tomorrow. So rows on the periodic table are called periods, and columns are groups. So protons and electrons increase as you move from left to right across the periodic table. Groups are the vertical columns, and they have similar properties. Groups, think about like a G. How can I remember this? Well, at the end of a sentence, I go along my entire sentence, and then I find a period. Okay, so periods are left to right. In groups, I have a G, it's up and down. That's how you remember what groups are and what periods are. So how do I classify elements? All elements are classified into three big groups. We call them metals, nonmetals, and semiconductors or metalloids. And they all share similar properties. Metals can be bent and shaped. They conduct electricity and heat, and they're usually shiny, although not always the case. Nonmetals have many properties in common as well, such as they're dull in appearance, brittle, and they do not conduct electricity. But semiconductors are intermediate conductors of heat and electricity. They're kind of in the middle, and they are actually really important elements for a lot of different properties. You think about where a lot of the tech is developed in our world, it's in like the Silicon Valley, which is named after a really important element in the development of our technologies, which is silicon. So if we look at the special groups now, this would be like a really specific type of element. In group one, we have our alkali metals, lithium, and then underneath it is sodium, underneath it is potassium. If you look at what all these have in common, just if you look at their structure, in the outer ring I have one, in the outer ring I have one, in the outer ring you have one. You might not know like what that outer ring is, but those are electrons. And in the outer shell, we call them valence electrons. So alkali metals have a single valence electron in the outside shell, making them very reactive. And if I were to look at alkaline earth metals, they would be similar, but they would have they'd be different elements, of course. So in here, the nucleus, a different element, but they would all have two dots or two electrons in their outer shell. So some of the groups have special names. We just looked at alkali metals and alkaline earth metals. We also have, halogens and noble gases, and metalloids found along the staircase. So if I look at my halogens here, if you notice, 1, 2, 3, 4, 5, 6, 7, 7, 7, 7, they all have 7 valence electrons, so they gain 1 to have 8 in their outer shell. Versus if I looked here, if potassium loses this 1, it ends up with 8 in its outer shell as well. So that's something we'll get to more later. But in the last column, group 18, we have a full set of 8 electrons, and they are not very reactive. So periodic table is organized by increased atomic number. Each box represents a different element, and each box also has a lot of different pieces that we'll look at more tomorrow. But when we're looking at the periodic table, now we see that alkali metals, alkaline earth metals, halogens, noble gases, metalloids, lots of different special types of elements. Best of luck. Let me know if you have any questions.